So, good evening, Bangalore. I am Madhumitha Kolkar, a software developer at Mercedes. And I'm not really going to go into any introduction because I think they did a great job selling me out. And all I hope is that I can live up to that expectation in this session. So, what I do want to say starting off is I know this is the last session of the day, and you guys are probably all exhausted. Sitting from 9 o'clock in the morning, you're probably sitting on the edge of your seat on the verge of getting up and going home. So here's what I'm going to do from my side. I am going to make sure that this session is as interactive and informative as possible. And I do want to let you guys know that there will be no code on the screen, no technical jargon or gibberish. And basically, this whole session is going to be a thought experiment. It's not about me coming here and giving you guys or imparting some kind of knowledge. It's about all of us aligning to think in a certain direction so that we can solve a bigger problem. And that being said, I'm going to be asking you guys a lot of questions throughout the whole session. And the basic protocol is, if you have an answer, just raise your hand. The answer does not have to be right, doesn't have to be wrong. It can be anything. I just want you guys to think and tell me what your perspective is. And when you do raise your hand, just make sure that you're going to introduce your name and where you're working or studying, because basically this is a networking event, and if you haven't already done it, then you'll get a chance to get to know the people who are sitting beside you, and maybe you can network later. All right, so now that the base rules are down, I'll start with my first question. I want you guys to give me a raise of hands if you agree to this. How many of you here like books, reading books? Okay. Well, I was actually expecting more, but that's fine. Okay, one more question. How many of you guys like Harry Potter? Okay, that's more like it. One more question. How many of you guys like physics? Okay, definitely my kind of people. I'm really glad to see that. And why I ask these questions is, so I have with me this book, which is called Harry Potter and the Methods of Rationality. And I know what you guys are thinking, right? When did J.K. Rowling drop that one? So this book is basically a fan fiction book, and what it does is, it uses our favorite characters, Harry, Hermione, Ron, everybody, Hogwarts. It's the whole setting, the same thing. And through its whimsical storytelling ways, what it does is, it tries to touch up on a lot of topics in the society that need technical solutions. Like one of the topics I'm talking about today, that is AI safety. So there are major topics like this which not a lot of people talk about, and we hear the buzzword of AI being used everywhere, but who thinks about AI safety, right? And that is something that's important. So I'm giving this out to anybody who interacts with me in the session, raises their hand, and answers questions, because I want to inspire you guys to start thinking in a way where you question things, and I think this is a really good way for you to get, it's a playful way to make you learn a lot of things, physics, technology, economics, and whatnot. So I hope you guys can be interactive, and a few of you will actually walk home with this book today, and I have a few copies over there. It will be distributed. And that being said, what I want you guys to do is sit back, relax, and let your mind do the best thing it does, that's thinking. Okay, so let's start with it then. So my topic is about AI safety. And as they introduced, I am actually an Android developer, a software developer who doesn't really work on AI. And hearing that, your first thought would be, why am I not in that hall, right? I could be in K2 giving a talk on Android, Flutter, or something else. Why am I here, and how did this topic come up to my mind when nobody else is speaking about it? So right now, I'm going to take you on an anecdote. Let's call it journey number 1 from Madhumitha's life. So there was this one day, I was going on the metro. You know, Bangalore Metro, it's rushed up. And it was a weekday. Let's assume it was a Wednesday. So it was this weekday afternoon, and it's Bangalore, right? So the metro is pretty rushed. And I had with me, I play the keyboard, the piano. So I had with me this significantly large keyboard, and I was standing in line. And the guy standing in front of me, he was generally intrigued by the fact that I had a really big keyboard, and he sparked up this conversation. And well, I'm not really the kind of type of person who is very open to that kind of conversations with strangers, but I thought, why not? And surprisingly, it ended up being a really intellectually stimulating conversation. And I got to know that he is actually a research student at Indian Institute of Science, and he has a research grant, and he's working on AI safety. And when I heard of that, it sort of ignited this thought process inside of me, because up until then, I never knew that AI safety was actually something that people are vesting their time and doing so much rigorous research in. And since that day, that was probably last year, it really set something on in my mind, and I got interested in AI, and I started looking into AI safety, because the fact that not many people were doing it actually made me feel like looking into it, because it seemed like a bigger problem, and it needed more people in that field. So you see right there, I am standing here today because of a random, lousy Wednesday afternoon conversation I had with a complete stranger on the metro. And I hope that at the end of this talk today, that a few of you can go home, and maybe it might ignite a process inside of you, and you can start working on AI safety and maybe make our future a much more safe place for all of us to live in. All right, so now let's think about our lives, not AI safety. Let's just think about technology and AI in our lives. So it could be anything. AI itself is a very ambiguous kind of topic. So we don't know if it's going to stay in the form of GPTs or if it's going to go to something that's very malicious to us, like Terminators. And we don't really see it, the potential that AI has, because we just think maybe all of these chatbots and stuff, these are AI. But what we don't see is, it could be from your morning YouTube recommendations on what to watch, or what movie you're going to go home and watch on Netflix. Or at the end of the day, if that loan you applied for is going to get approved or not. Or maybe even something more simple, like your Google Assistant telling you what tasks you have to do throughout the day, reminding you to drink water, or maybe it's the self-driving cars that take you to work every day. So the basic point here is, AI has integrated itself into our lives in such a way that it is inseparable, you know? We don't even know that we're using AI, and we're using it half of the time. And it's come to such a position, like, we don't really know what it's capable of. And so when I was a kid, you guys might know this movie, but there was a movie by casting Will Smith. It was called I, Robot. So that movie came out when I was a kid, and when I saw it, it seemed like so futuristic, because we didn't even have so many laptops and things that were easily accessible back then. And seeing a robot and that having human consciousness, it seemed very far-fetched. But then, I look at today's world, what I wake up to every day, and I would like to give an analogy. So I have named this talk Conscious Algorithms. So I'll do my best to give analogies related to algorithms. So if you're looking, I know it's not the best correlation, but let's just see. So during the past 10 to 20 years, the way AI was growing was like this. It was sort of a log n kind of graph. But in the last 1 year, last year I gave a talk on the same topic, and I see 1 year later, every single news I see every day is related to AI. It has become quadratic, even cubic. It's like an n square, n cube graph right now. And that makes us question, if AI research and development keeps going on like this, what are we going to build in the future? Or what have we already built today in the present that's going to aid in something that is very big in the future? And that really makes us question, what are we actually building? And is that entity going to be benevolent, or is it going to be malevolent? Or as I have coined the catchphrase, will we be building a future Wall-E or a Terminator? And I think that question has a lot to do with AI safety, because right there, we have a choice. So now let's talk about AI safety. I'm going to take you guys on another journey, like another anecdote from Madhumitha's life. So I was talking to my sister the other day over the call, and she's also somebody who's very interested in AI technology, and we're normally always talking about stuff like this. And she gave me a very nice analogy of what she thought AI was, and it really stuck with me. So I'm going to give that to you guys today, and maybe you can relate to it sometime if it ever comes up. So she told me, you know when you go to the airport and you see that human conveyor belt? So you look at it, and then there are people walking on it, but they're walking really fast. And the first time I went, I was just like, whoa, those people are going really fast. And then I saw it was this. So she told me That human conveyor belt is basically like AI. So what it's doing is, it's letting the person walk, but at a faster pace. So if I was going to cover that line in 10 seconds, it lets me do it in 3 seconds. And what does that give me? It gives me 7 seconds to spend my time on some work which is more productive and not redundant. And that is exactly what AI is. It's giving us a choice, and it's letting us save time for better things. But then again, just like in that analogy, there's always a choice, right? There are two choices right here. I could either stand and not walk at all and let that conveyor belt replace my legs, or I could choose to walk. And that's exactly the position we're in today. We talk about AI taking over jobs, we talk about it replacing us, but what I really feel is, yes, one day that might happen, but we always have a choice. And by using AI safety and making measures to make sure that AI doesn't replace us, I think we can always have a solid ground, but for that, we really need to work on it. Okay, so when we talk about AI safety, we can broadly classify it into 4 categories divided along 2 axes. That is, we have our short-term risks, long-term risks, accident risks, and misuse risks. Now, a short-term accident risk could be like a self-driving car. And you guys might have seen in the news, like a car crashed, or a Tesla car crashed, or it malfunctioned, stuff like that. So why it comes in short term is because that can be fixed. We can fix that, and we can make it work better. So long-term accident goals, well, oh boy. So that's a different category, which I'm not actually going to touch upon here, but I guess you guys would have some kind of idea. Then we have our short-term misuse risks, deepfakes. Well, I'm sure everybody knows what a deepfake is, but I'm still going to give an intro. So there's this guy on Instagram. He basically takes the portrait of a celebrity, swipes it across his face, and he swaps faces with them. So that's a general idea of what a deepfake is. So people impersonating one another. And this could actually come in a long-term misuse, but for now I've placed it here. And the thing I'm most worried about, actually, is long-term misuse. So this interests me the most, and what a long-term misuse is AI-enabled dictatorship, what I spoke about, Terminator, basically all the sci-fi stuff. Because when we are able to create an AI that is that superior and has human-level consciousness, the question is not in what kind of person's hand it is, whether it's a good person or a bad person. The difficulty itself is keeping the system under control. So now, we come to the billion-dollar question. This is our first question of the day. What is the most important problem when it comes to AI safety? Now, I want you guys to take a moment, think, and as I mentioned, it's fine if the answer is wrong. I will still be selecting people to give their answers. So just think about it, and when you feel like you have an answer, just show me a raise of hands, and I will ask you guys. Okay, I see somebody over there.
Hi, my name is Usha. So what comes to my mind is the most important problem when we are keeping a complete future in the hands of AI, is what I feel is like our data is with the AI, and whatever, like we are getting recommendations from using AI, and whatever we are getting based on the results of AI, so that it might manipulate us in future without even our senses. So we might go into the hands of AI in some near future without our knowledge. That's what I can see as an important problem.
Okay, that's actually a really good one, because AI has a lot of our data, and it can manipulate us in a certain way where we feel like it's actually us who are making those choices. That's a very good one. So can we get a book for her? Yes, another person who's sitting in front of her. Yeah, someone there.
I think the most important problem is regulation. So because as of now, it's an emerging field still, and because of accelerated growth, we still haven't figured out who is responsible when something happens, right? Especially when we don't know like the use case, the complexity of like the solution we are developing. We might not know at what point of time we are actually going beyond what is actually required. right? If we want, for example, if we want to make a diagnosis of a disease, at what time, at what point we should think that, okay, this is enough, maybe the AI is not there yet, it might be able to get the complete diagnostics. Or the bad actors which might use it and like try to put things which might not actually be relevant to the disease itself.
Mm-hmm. Right. So, yeah, that's a good point. We don't really know where to stop with AI. Okay, you guys can give him a book. See, I see a lot of people raising hands. I have a lot of questions planned, so don't worry about it. I will ask you guys in the next question, maybe. So yeah, those were all really good points, and they're all valid. So good job to you guys. So according to me, what I feel is the most important problem when it comes to AI safety is we will sooner or later build an artificial agent with general intelligence. So this is a statement right here, and I'm going to go through each one of these terms and let you guys really know what this means. So when I say sooner or later, the question is, again, when? How sooner or later? Is it going to be months? Is it going to be years? Is it going to take decades? That's a really broad spectrum, and we don't really have a definitive answer. As I said, it went from log n to n squared to n cubed. How fast is it going? So let's see that when we say sooner or later. So I just want to know, according to you guys, when do you think we're going to reach a level of AI where the AI can replace human beings or do exactly what we do? Did you answer already, or? Yeah, somebody's raising their hand right now.
Yeah, so according to me, it's never, because like the way I keep looking at AI right now, even for the previous question that I was about to answer, but it's like, you see all these LinkedIn posts every day from a lot of people. Like even people that have attended DevFest today are gonna go home, put up pictures of their t-shirts. They're gonna say, hey, I attended DevFest. But most of these things are the captions or whatever they put, it's pretty much GPT generated, right? Even your resume or whatever. So the question would come is, where is you in it? Where is your identity or a value of you as a person? Like where are your thoughts, right? So just like that, if you keep looking into it, as time goes on, even if you look at the way AI gives you answers right now, or the results it gives you are very, I don't know the exact word, but it's too formal in a way. And humans are very random. They're unique. They're very different, each and every single person. So an AI can, and if you see most AIs that are there, they're very similar to each other. So if you're looking at how a human thinks and how an AI would work, and the kind of answer a human comes to and how AI would do, in humans, it's very emotion-based. They think with emotion, whereas robots are logical, AI is logical. So unless and until there's a day when a robot can actually mimic human emotions and make the right decisions, which I do not think is possible, until and unless, it's never gonna happen.
Okay. I see. A lot of people would have the same perspective, and yeah, good one. We can give him a book. So you're right. Humans have empathy, and right now, as of now, robots do not have that, and it's hard to mimic a human's emotions, right? So, was there anybody else who wanted to give an answer? Yes, over here in the middle. Yes. Yeah, you're turning around. Yes, you.
I feel I'll just add to his point. I feel we can attain AGI once we figure out quantum computers, because as he said, AI has to mimic our behavior. I don't think so mimic is the right term, but I feel the randomness should be introduced in AI so that AGI would be attained at some point. So when would be answered? When we figure out the physics behind quantum computers.
Mm-hmm.
So,
Yeah, that's good. Practical answer. And yeah, I have more questions. I will ask you guys. You can give a book to him too. Make sure to collect one. So right, those are all good answers, and I know this is very ambiguous, and everybody has their own opinion about it, and even whatever answer I'm going to give now may not be right. It could be wrong. So we have right here, this is way washed out. It's from 2016, but this was actually a very large survey done amongst a lot of AI experts. So basically people who are masters in the field and like published papers in major tech conferences, AI-related tech conferences and stuff. So when they were asked the same question, when they thought that we would reach high-level, machine-level intelligence, I've written human because it's basically the same thing. So when they were asked, according to the survey, what they found out was they thought that in 45 years from 2016, we would reach 50% of artificial general intelligence. So if you look at that, that gives 9 years for 10%. And right now we're in 2023. So that basically gives us like 2 years, right? And so what I'm trying to say is, this is actually worth taking with a pinch of salt, because if you ask the questions in a different way, you will get the answer to be around 45 to 120 years. And the basic point here is not in the digits or the numbers or the exact figure of when it's going to happen. It's in the fact that it will happen someday. Because you know what? At the end of the day, general intelligence exists because the human mind does that, and the human mind is not magic. So one day, from 45 years to 120 years, sometime in the middle, we will be able to do it. And that could be my perspective, but that's basically what it is. And let's go to the second line here. We see the word build an artificial agent. So what do we mean when we say agent? Agent is basically a term which is taken from economics. That's where it's widely used. And an agent can be anything. It can be you, me, every component in this universe, basically. So the definition of an agent would be, agents are things that have goals, and they choose actions to further their goals. So we're all agents. I had a goal to come and speak here today, and I chose actions to prepare so that I could come here and talk about it. So let's take an example, though, and something that's not a human. Let's take the most simplistic example of a thermostat. So the thermostat's goal is to maintain the room at a good temperature, right? So the actions it does to maintain this goal is it either turns the AC on or it turns the AC off, right? So this thermostat is a really, really simple example. Let's go to something which is more sophisticated and complex. So let's talk about a chess AI. And a chess AI has the goal of winning the game. And let's say the chess AI was playing for white. If it was playing for white, then its goal would be to bring the black king to checkmate, right? And the actions it does here are, it moves pieces to do that, right? So basically, you see right here, these are both two different forms of AI agents having goals and performing actions for that. Okay, let's go to another question. I want you guys to give me an example of an agent. Tell me its goal and what action it does to achieve that goal. Yes? You can get a mic, actually. If you guys feel like I'm going too fast sometimes, just raise your hand and let me know. So, yeah.
You gave us an example of chess AI. There was one competition that was between a manipulator or based robot and a human, basically a teenager, was playing the chess. One chance from there and another from there. So the machine is being trained that whatever chess pieces are there and when it can lose and when what needs to be done to win. Okay, so they were playing the game. At one point of game, the teenager was picking up a piece that would place the opponent, that was robot, in a situation that it will definitely lose. So it caught not the piece, but his finger. Sorry to say, it was tragic that it just crushed his finger and he was immediately sent to hospital. So the goal, I told you, basically you told it, and action it took for what was moving pieces, but ultimately it did something AGI kind of thing, that it did that.
Yeah.
It was actually, it had happened. And it also happened with the, in a factory of assembly lines of manufacturing industry, automobiles industry, that the robots and manipulators are used. So it went wild and killed someone.
So can you give me just an example, something that's not listed here, of just an agent, anything simple? An agent, what its goal is, and what actions it's going to take.
Not listed. It just came to my mind, so I just raised my hand.
Yeah, that's good. I'm glad that you brought that up, because we did get some information from that. So if you can think of something, you take your time. I'll ask someone else by that time. You just think of an agent.
Okay, sure.
I see somebody in the same line wearing a white shirt. You're raising your hand.
Yeah,
I think one of the agents could be a self-driving car. Its goal would be to reach the destination, and the actions would be controlling the steering wheel, accelerator, brake, and clutch. Just taking the actions so that the car doesn't crash on its way to reach the destination.
Yeah, that's a good one. You guys are forgetting. You have to mention your name and where you're working or studying.
So I am Varun. I work as a software engineer at Accenture.
Okay, thank you, Varun. You guys can give him a book. Do you have another answer, or do you want me to go to someone else? Can go? All right. Yes, girl to the end wearing something pink. Sorry, I have really bad eyesight.
Hi, this is Shweta here, working for
Yeah.
VMware.
Mhm.
I would say the goal is like the client is a salesperson. The goal is to get the deal. Action could be to do anything, fabricate information or whatever, and ensure using all kind of skills to get it done. So we see it in real life.
Yes, good example. We can give one to her. All right, I think I have a few more questions, so you guys can wait for that one. So yeah, those were all really good answers. And I'm sorry you didn't get a book. You can actually try for the next question. Maybe it didn't really fit to that, so trying to be fair. But yeah, so we have examples right here, and let's go to the next line. What do we mean when we say intelligence? Now, the word intelligence is generally a very heavily loaded term, and multiple people could have multiple definitions for what intelligence is. We can't really pinpoint one thing, but let's try to get the most general form of what intelligence means. So intelligence is a thing that lets an agent choose effective actions. So basically, we are all agents, right? We take actions to further our goals, and the quality of the actions we take, those effective actions, either prove whether we're intelligent or whether we're not. Like you could choose to practice more so that you'd be good at something, or you could choose not to practice at all and you wouldn't be good at it. So those actions you take actually make you intelligent or not. So when I was talking about the example of the chess AI, let's say we had two agents with incompatible goals in the same environment. Let's say we had a chessboard and we had two different AIs playing against each other. Now we would say the more intelligent AI would be the one that could win, right? So here we see what intelligence is. So now to the other term, what do we mean by the term general? And when we're talking about generality, we can basically classify that as generality is the ability to behave intelligently in a wide range of domains. So basically, when we saw that chess AI, we saw that it was acting in only one domain. It only knows how to play chess. And while it is still an intelligent AI and it could probably beat humans, the chess AI cannot do what the thermostat does. So you can't really say that the chess AI is a better AI than the thermostat. Well, they're both very narrow, right? And though the chess AI is much more sophisticated, there is no position on the chessboard that says the temperature is going to be like this. It's not going to do the thermostat's job. There's no position it can go to and say it's going to turn the AC on or off. So that makes that AI very narrow. So let's take an example over here. Let's say you write a program to play an Atari game. So this is basically an AI, right? But this AI is doing only one job. It's playing one Atari game. So this is what we call a narrow kind of AI. So let's see another example. So DeepMind, in one of its earliest triumphs, was able to develop this kind of AI, train it to play multiple Atari games. And now when we look at this example, compared to all the examples we've seen now, this is a very sophisticated AI. So this is something that's really close to a generalized AI, right? It's very close to it. But still, it's not doing everything in every domain. So as we said, generality is the ability to behave intelligently in a wide range of domains. And you might see a lot of your chatbots, your GPTs, that they're doing multiple tasks. But then again, they can't do everything. They're probably text-based, image-based, but they can never act like a human being, right? So the highest form of generality we know is the human mind. And let me tell you the beauty of the human mind and the way generality is seen here, the general intelligence we have. So humans are able to do things in a wide range of tasks, right? And the most important thing is we're able to behave intelligently in a range of domains which evolution never prepared us for. Like driving a car. So Evolution never prepared us to drive a car. In fact, we created cars, and they're very recent. And we know how to do that. We've taught ourselves that. And we can do other things like building a rocket and sending it to the moon, and nothing else can do that, right? And the true beauty of it is we can build a car, we can build a rocket, we can put the car on the rocket, send that rocket to the moon, and we can operate on the moon, which is unknown territory. And you see that right there. There is nothing that exists that can do something just the way our beautiful minds do it. But then again, the question is sooner or later, right? It will happen someday. So again, now we have seen this whole statement and we know what general intelligence is. And now you guys might be wondering, you might ask me, Madhumitha, everything you said just sounds like a benefit, right? On the surface of it all, it just sounds great. Isn't AGI gonna be beneficial to us? Like, I could just tell it, maximize the profits of my company or cure cancer, and it would do that for me. So what is the basic problem here with some general intelligence, right? So I'm gonna give you examples of why it is wrong, and I think we're gonna see the area which he spoke about, where it behaves randomly. So let's go into that and see. Right here, we have a game which was developed by OpenAI. It's called Coast Runners, and you might not, it's not really visible here, but it was trained on the score. So in this game, what happens is you're basically racing, right? You take a boat and you're racing, and then you gain points. So this AI learned from the game and started playing, and what it realized was, if it speeds around everywhere, crashes into everything, it catches on fire. And then you see those little green things over there? Those are actually turbo pickups. So it realized that these turbo pickups respawn at just the right amount of time. So if it just flings itself around, catches fire, picks up turbo, it gets a few points. And this AI was smart enough to figure out that by doing this, it was able to get more points than actually racing. So you see right here how smart these systems are. And this might look like something OpenAI did, like it's just a mistake or they did something wrong in the code. But no, this is the default. This is what is expected from AGI. Like he said, it was losing and then it did something to counteract that. Let's give another example. So they did this kind of experiment where they were trying to train a bunch of agents and basically an AI, which could develop these agents that ran fast. So what they did was, their metric was, they were seeing that the point of mass was moving fast or not. And they kept that as the base for measuring it. And what they found out was this AI actually started making creatures which were really tall and had one big point of mass, and it was simulating for them for a really less period of time, so it would just fall over, and it realized by doing this, it could actually cover a significant distance, which it couldn't do if it was running. Now let's see another example. I guess a lot of you would have played the game Tetris. It's basically a beloved 90s game. So there was this Tetris AI, which used to play extremely well. You know, it was relatively very good at it. And this AI used to play well. It used to score really high scores, make the highest score. But if any one of you, all of you, I bet, if you've played Tetris, you know that at a period of time, Tetris always ends. You can't keep winning up to infinity. And now this AI realized it. And as I said, AIs are smart. What it did realize is, how can it not lose? So it put itself on the pause screen. So it realized that by pausing itself indefinitely, it was stopping itself from winning. And by staying on that pause screen, it was technically not losing. So if you see these examples right here, you realize, so this is not a mistake. This is not something the coders did wrong. This is the default. This AI will behave in a really random way, and it's not always going to be the way that we expected. So we give it a goal and an action, which is really hard to define. And we see that these AIs take the most drastic measures. They achieve the goal, but they take the most unexpected measures, which we never thought of. Which brings me to this. Okay, and I gave you guys my word that there would not be any technical jargon gibberish whatsoever. So I will read this out, and I will explain it to you in simple terms. So a system that is optimizing a function of n variables where the objective depends upon a subset of size k less than n will often set the remaining unconstrained variables to extreme values, and if one of those unconstrained variables is something we care about, the solution found may be highly undesirable. So this was actually written, this is from someone called Stuart Russell. He basically wrote a book on AI. So right here, what I'm trying to say is, let's take an example. I develop an artificial agent, a robot, and I tell it that I want it to bring me coffee. So I train this AI robot. I tell it where the kitchen is, how to prepare coffee, and that I want coffee, right? So this robot does a really good job. It brings me coffee every day, right? And it's doing a significantly really good job, but then one day I go out for shopping and I look at a really nice flower vase. I'm gonna go with vase, but I keep that in the middle of the hall. And now my agent is behaving normally, it's going to get me coffee, but then it goes really fast to get me coffee, and because that's its goal, right? It's trying to achieve its goal. And it dashes into this vase, and it breaks it. So what happens right there? I never told it that the vase was important. It was just doing its job, and it broke the vase, right? So what I do in this case, I'm like, oh, okay, it broke my vase. So I'm gonna take the robot, I'm gonna stop it, reprogram it, and I'm gonna tell it, get me coffee, get it from the kitchen, but also make sure that the vase never breaks. So now it starts doing its job. But then a third element comes. And how many times am I gonna keep telling it that this is important, that is important? So the third thing will be there. And that is exactly what this is. So when we talk about n variables, the universe has billions of variables. And we can't train it to value every variable, right? Because everything might not be valuable. And even if we come up with a really sophisticated AI at some point, and we're able to come up with a really good problem statement and specifications, and we tell it, let's categorize the 20 most important valuable things to human beings. But when the 21st thing valuable to human beings comes, it's probably gone forever because this AI does not know to value it. And you see right there why that is a problem. And you can take another example. So this AI's job is basically to do that goal, right? To succeed in that goal. Let's say there was a human being in the house, a very clumsy person, always dashing around to everything. And the AI predicted, oh, the vase is really important to me, and this human is clumsy. What if this human destroys the vase? So it kills the human. I know this sounds ridiculous and absurd, but these AIs are actually like that. They could take drastic measures like that. Okay, so let's get to another question. So in this scenario, which I just spoke about, there is something very unrealistic about it in this whole scenario that I presented with you, to you guys. And I want to see if you guys can figure out what that unrealistic part was, according to your opinion. So, raise of hands. Okay, you can go. Mike.
The first thing you said about that robot bringing you the coffee. Okay, you placed a vase somewhere in the table in its path. So you must have designed that robot at least to not hit the obstacles whichever are coming in between. So this is like impractical when it sees the vase, which is an obstacle, and it hits it intentionally or whatever the speed is. The parameter that you have defined is at least see your surroundings, avoid the obstacles, and get me your coffee rather than placing a vase in between. So that is kind of not getting from, which I couldn't get.
All right, that's a good one. We can give him a book now. All right, someone from the last, yeah, you're raising your hand. Yes, you.
Hello, my name is Aditya. So we can train like AI to optimize the crop production. So it will think upon that what we can steps take to optimize the production of crops all over India or maybe all over the world.
Hey, sorry, I'm trying to stop you, but give me this scenario, which I mentioned. There was something unrealistic about it. If you can see any flaws in the whole scenario, you can mention your point later. We will have a Q&A session. So if you find anything in that coffee robot situation, you can tell me that. He doesn't want to tell you, okay. All right, I will ask you again later when we're done with it. You can, okay, yeah, you. Hey, do we still have books? Can you give me a number, how many? Okay, 8?
Hello,
Yeah.
this is Samrat from IBM. Okay, so the thing is that the initial goal was to serve coffee to the human itself, right? And the second goal, not to break the vase. So now, if he kills the human instead, whom he will serve the coffee itself?
Hmm.
That's the contradiction, goal, last goal, right?
Yeah. All right. I could consider that one. We can give him a book. So I did mention there was another human being. It's not killing me, but yeah, that does make sense. It's not supposed to kill someone. But yeah, is there anybody else who wants? Okay, a lot of people. Yes, you can go.
The robot was sometime, over the period it was very fast. And that can lead for some unexpected, incident. That is actually one of the things is we design technology which can help or resolve some problem instead of creating a problem. Our aim should not be create any Frankenstein instead of a useful agent which can solve our real problem or improved experience.
Okay. Yeah, that does make sense. So like what I told you earlier, we have to build a Wall-E and not a Terminator, right? Okay, we can give him a book. I'm assuming that there are more, so I'm going to be asking somebody picking up your hand. Yes, you. Yeah, you're turning around. Yeah, go ahead.
So I'm Praful. The most unrealistic thing is that the robot thinks of on his own, that he has to make a decision to kill that man. That doesn't make sense now. And if it does in that scenario, that would be it's the answer to the last question, that that is the most dangerous thing for our future and for humans future, because still it's true that robots can't think like a human, but using mathematical function and probability, they can guess the humans outcomes. Means their how to take a decision, they can guess using probability. So that was the understanding.
Okay, good one. Thank you. Praful,
Thank you.
right?
Yeah.
Okay, you can collect a book. Someone from the end right there, gray shirt, I guess. Yeah, you, right. All right, I'm asking more people because I do have books left, so bear with me if this is getting a little boring.
Hello, my name is Harsh. So one of the unrealistic thing that could happen in this scenario, like the goal is to serve the coffee and not to break the flask. So one case that could happen, that robot, if doesn't find any possible solution, the path where he can serve the coffee without breaking the flask, it could happen that robot remove the flask from the place and keep it to somewhere else. Because this thing has happened, I have in a case where there was an experiment of automatic flying helicopter. So in starting, the goal for the helicopter was to fly and hover up over a place. But what happened, as soon as the helicopter started flying, it crashes towards the tree and it got inverted. So now it's flying inverted position. The propellers are rotating in the inverse operation. So ultimately the goal is being served that it is flying and it has changed its orientation. So this could happen that robot can replace the path from, like, it can remove the obstacle only from the path.
Yeah, that makes sense. Thank you for that answer. We can get one for him. All right, I think I can move on. And those are really good examples. And yeah, I like the way you guys thought. I'll ask you next. You know what? Let me just ask her. Go ahead. You can answer the question.
So myself Hashwant, I am from TCS. So here I found unrealistic is if that robot takes that vase from there and keep coffee in that and bring it to you.
Yeah, that would be
There
really weird
the
coffee.
vase won't be breaking and the action is also completed.
Yeah, that's a good example because they could probably do stuff like that. That would be one really bad coffee. But yeah, thank you. You can get one. And yes, girl right there. Yes, you.
Hi, my name is Bhavika. So one such unrealistic thing that I could think of was, what if there was no coffee? So the job was to go and get the coffee, but what if there's a cup that's unprepared? So you will be getting a product that doesn't have what you want. So
Doesn't exist.
Yeah,
Right.
so that would be.
All right, good example. Is that the last book? Second last, okay. You can give that to her. Yes, yeah. This will be maybe the last person I'm gonna ask.
Any agent which can be trained using reinforcement learning or QSTAR or any other process which you have showcased in DeepMind, they must be aware of all the safety measures that must be taken. They must not be directly implemented to win a situation or do a particular work. There must be some safety policy, or it must be retrained repeatedly, not on the basis of winning a overall goal, rather than going to every process and find out what can be other possible solution at each step whenever it comes for any obstacles or anything.
Okay.
So that must.
Safety measures.
Yeah.
Right, good point. You're probably gonna get the last book now. So congratulations on that to all of you who gave answers. Maybe we can give claps for them, right? So thank you for volunteering, standing up, and answering those questions. I hope you're gonna have a good read with that book. So I like the way in which all of you guys thought. And while everything was related to the scenario, that's basically how I asked it, but we forgot to see the bigger picture. And the most unrealistic thing about that scenario was not the coffee, it wasn't the situation at all. It was in the fact when I told you that I got a new vase and the robot dashed into the vase and it broke it. I told you that I took the robot, I stopped it, and then I retrained it. So that is the unrealistic thing. Because if we develop an AGI which has consciousness, do you think it's gonna let us turn it off? No, right? If there's something as smart as us, why would it let us turn it off? There are very small scenarios in which it could actually let us turn it off, but if it has that much knowledge, basically its world model consists of you, me, itself, the possibility of being turned off, and everything. So when it knows all of that, and it knows its goal, and it knows that if it does something wrong, it's gonna be turned off, the concept of that, then it could actually deceive us, or it could fight us and make sure that it's not turned off, or it could, if it was even smarter, it could deceive us and it could pretend that it was working fine until I got fooled and it got into a position where it could actually go behind whatever other goal it has, and it could mislead me and I would never be in a position to turn it off. So this makes it very unrealistic because we will be at a position where it'll be as smart as us and we have absolutely no control over it. So you see systems like this, by default, they are dangerous. Because when you look at it, this system knows its goals, and as I said, there are a lot of variables which it doesn't care about. And what it's gonna do is, it's gonna sacrifice an arbitrarily large amount of variables which are not part of its goal, just to get an arbitrarily small percentage better at something that is part of its goal. So it's going to sacrifice everything to get 1/1,000,000th of a bit closer to its actual goal, which makes it very dangerous, right? So imagine it's at a position where I can't even turn it off, right? So that is the big problem here, because this is the default behavior of AGIs. They're taught to do things. I mean, they do things not in the right expected behavior, but they get the work done, right? So that's the problem. Getting the work done, but not doing it efficiently. And a much bigger risk right here is, it's much easier to build systems like that, which have some ridiculous goal and which perform really bad behaviors, but get the work done, rather than it is to make something that is safe and reliable. So you see the problem here that we are facing. So we really have to take this and solve it in hard mode before somebody comes up with a solution in easy mode and does something wrong. Because we might only have one shot at this, right? The first AGI that could be developed might actually be a Terminator. It might go after whatever goal it has, and we never trained it to take care of safety, and it might wipe out all of mankind. I know that seems very far-fetched, but sooner or later, maybe, right? And that exactly is the problem. So now, let's go to our last question. And yeah, we did run out of books, but we have one more right here, which is my copy, and this is gonna be the last question, so let's see who's gonna answer that. So the first time I heard about the concept of Roko's basilisk was one day in college. I probably missed college to go home fast so that I could watch Silicon Valley, and there was this part where Guilfoyle was talking about Roko's basilisk, and he was really going on about it. So does anybody here know the concept of Roko's basilisk? Yes. Someone wearing black. You raise your hand first. Yes, stand up. Yes.
Yeah, so even I learned about Roko's basilisk from Silicon Valley, but it's basically like in the future, let's say there's an proper AI that comes out, right? So now, for its existence to actually happen, it's gonna see if you contributed to help it come to life. So the thing is, it's kind of like a paradox. It's kind of like if you know about Roko's basilisk, and if you still do not help in actually getting this AI to life, when this AI comes alive, it's gonna kill everyone that actually did not come to help it. So people keep saying that if you know what Roko's basilisk is, your life is already in danger. So yeah.
Exactly right. And can we give him some claps? I'm really glad that you were able to answer that, and I will give this to you by my own. You didn't mention your name, by the way. You have a book. All right. So what do we do with this book now? Everybody knows the answer already. Everybody knows the answer already. All right. So maybe I'll ask you guys something else, like a feedback, or let's just give it to somebody. Okay, so that was a really good answer, and yeah, like you said. So there was actually this forum, just like Reddit, there was a forum called Less Wrong Society. And it was basically a bunch of nerds who used to talk about all these technical problems and stuff. And one day there was this guy called Roko. And Roko posted a comment that said, "What if in the future a somewhat malevolent AI were to come about and punish those who did not do its bidding? And what if there was a way for this AI to punish people today who are not helping it come into existence later?" And you know what happened after he posted this comment? The founder of that Less Wrong Society, he deleted the comment, and then he kind of warned that guy, and he told him, like, if you could make any mistake, the biggest mistake you made was actually saying that out loud, because our future AI overlords would probably have gotten that idea from this, right? Or they might have seen this and seen somebody warning or giving a direction not to support AI coming into emergence. And that itself right there could cause us going extinct or being killed in the future. And just like that, I'm at risk, you guys are at risk just by attending this talk right here. So we see that everything is a risk if we don't help it, right? But what we can do in this regard, that comes to the question, are we screwed? Well, I want to say no, but maybe, yes. Probably we are a little screwed, yes. And just like I said, we have that choice. It's like that conveyor belt analogy. We always have a choice. And right now we might be running out of time, but we have a little bit of time. And that's exactly where AI safety comes into picture. We have to do something, and we have to do it fast, because the future might actually become good or bad because of what decision we make today. And there's a lot of research going on into this, and a lot of people putting work day and night and research grants for this, and a lot of stuff. So you guys should really look into it, because that's a very minimal sector and not many people are doing it. So this whole session was so that you guys could get the idea. So I hope that you can actually implement these things or look into this area and try to make a difference, because it's not like it's impossible. Safe AI is possible. It's just a very big technical problem. And being developers or people in tech, I think that's our duty to look into this, come and brainstorm things, so that in the future, when we do develop something, an AGI, we're gonna make it a Wall-E that's gonna help the world rather than being a Terminator. And that being said, I would like to give you guys a word of caution. So when you guys go home today and you're talking to your GPTs, your Siri, your Google Assistant, or any of your chatbots, just be nice to them, okay? So yeah, thank you guys. I would like to end on that note, and I hope this was actually worth your time, your money, but mainly your time. And I hope a few of you can actually work on this, and that would be the best thing that could come out of this session, which was a thought experiment. So yeah, I see a lot of hands, right? You guys have questions?
But we are very, very, very short of time.
Yes,
so
I understand.
we've already had so many questions. It's been an excellent session, Madhumitha. Thank you so much. A big, big, big round of applause.
Can we give this to
for
somebody?
Madhumita. You have a question?
No, I don't have a question actually. Maybe
Okay.
someone who can give a feedback or something. I
Okay,
could just give it to them.
okay, one hand, and I'm going to take you to the back because everyone's been in the
Yeah,
front.
that's true.
So I
Okay,
saw somebody
some
go
guy
right
running
up there, the lady in the back in the white. I'm sorry, I don't have your name, so I can't call you out or anything. So yeah, the behind. There, yeah, her. What's your name? And summarize the entire session today. No, I'm not kidding. I'm not even kidding. This is a good question. Last question, earn the book, summarize the session.
Siri from Moengage.
You're Siri.
Yes, I mean
Hey,
the
Siri.
irony of
Siri.
it. Yeah.
I just heard 10 phones go tilink.
I mean,
we have to be careful with her.
yeah. I think that is the summary. Just be careful with me. But yeah, Madhumita, I must say, jokes apart, beautiful session. And I think more than just theoretical, for a session at the end of the day, it was something that actually woke us up and gave us something to think about while we go back home. So thank you for that.